All right, so let's go on page 49 when we're done. So in order to solve equations with rational exponents, the first thing we're going to do is isolate. Okay, isolate, which means get it all by itself. Isolate the term containing the rational exponent. That has to be all by itself. Okay. Once we have that done, we're going to raise both sides to a power. So we're going to raise both sides of the equation to the power that is the reciprocal. What does that mean? How do I find the reciprocal of a fraction? I just flipped over. Exactly. The power that is the reciprocal of the given power. So we don't even have to make decisions here. We know exactly what we have to do. We just take what we have and we flip it over. Then the next step is to solve for x. Okay. Then, like we have to do in some equations, but not all, but this is one where we do have to do this, we have to check for extraneous solutions. Okay. So we solve for x, then we check for extraneous solutions. This is an important one that we can't forget. And then this one's important as well. It starts with beware. Beware. There are two solutions when the rational exponent, okay, so when the rational exponent is an even number over an odd number, then we'll have two solutions, and I'll show you why as we go through this. Okay. And as we go through this, when we did rational exponents, there was more than one way we could handle this. We could change it to root form, or we could leave it in fractional exponent form and do some stuff with the bases, and there's more than one way to work it. So when I was trying to decide exactly how to approach these problems with y'all, I just kind of went with what my first instinct was, because I thought, to me, my first instinct is usually myself trying to make it a little bit easier. So I'm going to show you the different ways, but then I'm also going to tell you why I think one way is better than the other. So when we look at number one here, we have the first step is to isolate the term that has the rational exponent. Well, it's already isolated. It's by itself over there. So then the next thing we do is we raise both sides to the power that is the reciprocal of the rational exponent. So this becomes 3/4. This becomes 3/4. Okay? So the reason we're doing that is because when I take x to the 4/3 power to the 3/4 power, when I multiply those, the 3's cancel out and the 4's cancel out, so I end up with just plain old x. And I get x equals 16 to the 3/4 power. Okay. Now, this was one of the ones that was beware, because what we started with was 4/3. That's an even number over an odd number. And so that means if, let's say that I want to do this where we're just going to change the base to the smallest number. So I can change 16 into a 2 to some power. Would you agree with that? So I could say here that this could be 2 to the 4th power. That's the same as 16 to the 3/4 power. Right? And then we end up getting 2 cubed from that. Okay? Does that make sense? That's one way we can do it. But because we started off with an even over an odd, then I also need to say I'm going to have -2 to the 4th to the 3/4 power. Now, how do you remember to do that? And yes, it's even over odd, but do you always remember that? I think in these cases, maybe it's better not to do the fractional exponent part, and maybe it's going to make a little bit more sense to do it with the roots, because a third way, and the way I think I would probably work most of these as I went through them, but again, it's up to you. It's a matter of opinion what's easier. But I can rewrite this, make sure we agree, as the 4th root of 16 to the third power. Do you agree that that is the same thing? Like those are the things that I could rewrite. Now, if I do it that way, I clearly see that I am taking an even root, and that's why you get the plus or minus, because if we take the square root and we introduce that, right, we get plus or minus in there. And so since that's that 4, that's an even root, that's when I have to take into account the plus or minus. So to take the 4th root of something, you take the square root, and you take the square root again, and the square root of 16 is 4, the square root of 4 is 2, right? So this would be plus or minus 2, but then this has to be cubed. So we know to put the plus or minus because it's an even root. I mean, maybe that'll help you remember to do that. Which means then I have to do 2 cubed and negative 2 cubed. So I get x equals 2 cubed is 8. What's negative 2 cubed? Negative 8, right? Because negative times a negative gives you negative. So that's where we get our 2 answers from. What questions do you have? So the stuff I wrote in dark pink right here, you wouldn't necessarily have to do it. You wouldn't have to write all 3 of these, obviously. But if you do it this way, you have to make sure you remember to do 2 different things, which I don't know if we would always remember that. But now that I have these, my next step is that I have to check it. I'll put CK for check. I check it. So I'm going to take my 8 to the 4/3 power equals 16. Okay? And whether you rewrite it or whatever you do, you know, if you take it to the 4/3 power, that does mean we're taking the cube root of 8. So the cube root of 8 is 2. So then we get 2 to the 4th equals 16. And then we get 16 equals 16. And we're good to go on that one. Okay. Then if I have negative 8 to the 4/3 power equals 16. Well, the cube root of negative 8 is negative 2, and negative 2 to the 4th power, we have to equal 16, and there we would get positive equals positive again. And this is one of those times where your parentheses are matters, because if you don't have parentheses around that negative 2 to the 4th, and if you look like this, if it looks like this, negative 2 to the 4th like that, that is equal to negative 16. Because you take 2 to the 4th and then you make it negative, right? So when we're substituting this in as x, even if you want to do it on everything you do, putting the parentheses around there to be safe, just make sure you know where the parentheses are and what they mean. So that these both work, so these both are my answers. Okay. What questions do you have? All right. I would not skip any steps on this stuff because it's easy to kind of think of things backwards sometimes, I think, even if it seems simple. All right, so step 1, remember, is to isolate the term. So I've got to isolate this term, which means I'm going to subtract 6 from both sides. So I'm going to get 3x to the 1/2 power equals negative 6. Okay. So when I first started this question, I was like, oh, I have a negative and a square root. I'm probably going to get imaginary. That was just like flew through my head. But then when I actually work this, that's not what happens at all, just by the nature of what we're doing. We're going to raise both sides to the reciprocal of that 1/2. Well, the reciprocal of 1/2 is 2. So that makes that become 1. So I get 3x equals 36, because negative 6 squared is 36. And then x equals 12. And I only have one answer because I started out with an odd over an even. I'm going to start off with that. Plus, I didn't end up taking a root anywhere. Everybody good? Are we done with this? What do we have to do? We have to check it. So we're going to come over here. We're going to check it. We have 3 times 12 to the 1/2 power plus 6 equals 0. So that's 36 to the 1/2 power plus 6 equals 0. What's 36 to the 1/2 power? 6. So I get 6 plus 6, and that does not equal 0. Now, sometimes when we take the square root of 36, we get plus or minus, right? That's when we introduce the square root. We did not introduce the square root. It was there from the very beginning. So that's why it's just a plain old 6. Okay, so that means that that is not true, so this is extraneous. And the answer is actually no solution. Now, little things like, the answer is no solution. Will your professor next semester require you to write extraneous and require you to show that and mark that out? I have no idea, because that's more a preference from a teacher trying to make sure that you know what you're doing, you're writing stuff down, not necessarily like the rule for solving it. So just pay attention to that if that is something that's expected of you. What questions do we got? Anything? All right. Let's flip it over then. So we have to isolate the term that has the rational exponent in it. Boom, that's what that is. Okay, that's already, it's got parentheses around it, but that's fine. Or we've got more than one thing in there. So now I'm going to take this whole thing to the reciprocal, which is 2/3 power. That means this gets taken to the 2/3 power. So then I get x minus 1 equals, and if, again, I think maybe it makes a little bit more sense to you with roots. I mean, maybe not, but it's, you know, it's up to you. You could rewrite this as the cube root of 8 squared. I think sometimes that helps you get your brain wrapped around what you're trying to do here. And so what's the cube root of 8? 2. So this is really x minus 1 equals 2 squared. So x minus 1 equals 4. Now, if you skip this step and you do this, you're like, oh, the cube root of 8 is 2. I square that, I get 4, and you go straight to here. That's totally fine. Just writing that in there so I don't lose anybody. And you know whether or not you need to skip steps or not, because some of us probably don't need to. And then x equals 5. Then I have to check it. So I do 5 minus 1 to the 3/2 power equals 8. Okay, so 5 minus 1 is 4. So this is really the square root of 4 cubed equals 8. Well, the square root of 4 is 2. 2 cubed is 8. So we get 8 equals 8. That is a true statement. Therefore, that works. Any questions at all? And that was odd over even to start. Plus, when I did it like this, then I'm seeing the root. That's an odd root, so I just go with whatever the sign gives me. I don't have to worry about a plus or minus. All right, so number 4. Let's first make sure we know how to isolate the term. This is what I want to isolate right here. So no making up math. You do the same stuff you've been doing forever. The first thing we're going to do is move that 1. So I'm going to get -3 times 2x plus 4 to the 2/3 power. And that equals -12. What do I do next? Divide by -3. Good. So then I'm going to get 2x plus 4 to the 2/3 power equals 4. Because I divided both sides by a -3. Everybody okay with all that? So now I'm going to raise both sides to that reciprocal power. So 3/2, 3/2. So that's going to give me 2x plus 4 equals the square root of 4 cubed. And I highly suggest you write that down, even though it might be something kind of easy for you to do in your brain, because now you're looking at that, you see an even root. I'm taking the square root, which means we have to have a plus or minus. Okay? So I'm going to get 2x plus 4 equals a positive 2 cubed, and 2x plus 4 equals a -2 cubed. Okay, because you end up with the plus or minus there. It's because I'm taking an even root. Everybody okay with that? See, every little step in here, the little steps in between, they're not necessarily difficult. You just got to make sure that you don't forget things or make up math. So then this ends up being 2x plus 4 equals 8. So 2x equals 4 and x equals 2. So there's one solution that I found so far. then this would be 2x plus 4 equals negative 8. So that means 2x equals negative 12 and x equals negative 6. And I'm underlining them just so I don't lose them in my work, right? I'm not ready to box them yet because I got to check them, but I'm underlining some. I can go back and find them since it's all kind of crammed together. Everybody with me so far? Then we got to check them. All right, so now I'm going to have negative 3 times 2, and then the first one I'm going to do is the 2. So 2 times 2 plus 4 to the 2/3 power plus 1 equals negative 11. Okay. So then I'm going to have a negative 3 times, all right, so 2 times 2 is 4 plus 4 is 8. So this is like the cube root of 8 squared plus 1 equals negative 11. Cube root of a positive 8 is 2. 2 squared is 4. So I'm going to get negative 3 times 4 plus 1 equals negative 11. So that, I think we can see there that that's going to be true. It's okay that you don't, finish it off. Clearly, I'm going to have negative 12 plus 1. So I think I feel good about that. So I like this one. And then let's do the negative 6. Negative 3 times 2 is negative 6 plus 4 to the 2/3 power plus 1, negative 11. All right, negative 3 times 2 times negative 6 is negative 12 plus 4 is negative 8. So I'm going to take the cube root of negative 8 and square it plus 1 equals negative 11. Well, what's the cube root of negative 8? Negative 2, and then when you square it, you get 4. So we get negative 3 times 4 plus 1 equals negative 11, which means we're in the same spot we were there. So I actually like both of those. What questions you got? All right, y'all want to try one on your own? Okay, y'all do the next. You do number 5. Remember, you got to isolate those parentheses first. That's step 1. Make it. Good. Don't forget to check it once you think you have an answer. Okay, before checking it, so far. What's 2 to the 5th? Is that what you're trying to figure out? I like to do my fingers, so go. What? So it's 2, 4, 8, 16, 32. So I'm going to check it. So I'm going to get 12 times 3 times 11 minus 1 to the 1/5 power equals 24. So this is 12, and then 3 times 11 is 33 minus 1 is going to give me 32 to the 1/5 power, and that equals 24. So 32 to the 1/5 is the 5th root of 32, which the way we got it was by taking 2 to the 5th. So we'll go backwards, we get 2. So I get 12 times 2 equals 24. I feel like that is a true statement, so I like my answer. Okay. What questions do you have? Or where were you getting stuck? Because some of y'all were like pausing for a while or having some discussion. Where are we with this? Anybody brave enough to tell me what's going on? What happened? No, just like yeah, okay. Do you understand that the 1/5 is the 5th root? Okay. And then when those things happen, or when you get in those numbers, think about what else you did. Because sometimes, not always, but sometimes in the problem, you can go, oh, look, I went from here to here, so it's just going the opposite way. And like you literally already did it, and it's in front of you, and then your brain is just not recognizing that. But thank you. All right. Anybody have anything else to add? Anything else we're getting stuck on or whatever? And when you do these enough, most of the questions are, we're going to be using decent numbers if we don't have a calculator. So you're going to be doing 2 to the exponent so many times, you'll start to recognize them a little bit better. It won't be that big of a deal. All right, so let's look at 6. So on 6, I have, this is already isolated, so I just need to raise both sides to the 2nd power. And when I do that, I get x squared equals, then this is just, right, just becomes 1. So this is x plus 12. Now, I cannot solve this exactly like we did all the rest because I have that x squared there, right? Which means it's what kind of equation? Starts with a Q. Quadratic. Okay. Thank you very much. I knew y'all knew it. It's quadratic. So when it's a quadratic, we have to pause for a second and say, don't make up math. The first thing you usually want to try is setting it equal to 0 and see if we can factor it, right? So I'm going to set it equal to 0. That means, and I want x squared positive. X squared minus x minus 12 equals 0. Then I want to see if I can factor it. If not, I might have to do some other things, but this looks like it's going to factor pretty nicely. 12 is negative, so the signs are opposite. What are my two numbers here? -4 and 3. Good. Okay, because I have to multiply negative 12 combined to give me a -1. Right? So that means my answers are x equals -3 and x equals 4. And then I'm going to check them. When I go to check them, that means I'm going to have, let's see, we'll do -3 first. -3 equals -3 plus 12 to the 1/2 power. So it would be -3 equals 9 to the 1/2 power. Well, what is 9 to the 1/2 power? 3. And those two things are not equal, right? And this is not one of the cases where we got to put a plus or minus because we didn't put the 1/2 power in there. It was already there. Those are not equal, so this one does not work. It's possible that they both don't work, so we got to check that other one. 4 is equal to 4 plus 12 to the 1/2 power. So that's 4 equals 16 to the 1/2 power. What is 16 to the 1/2 power? 4. 4 equals 4. I like that one. That is the only answer we get out of it. Okay? So it's possible that all of your answers work. It's possible that none of them work. It's possible that some do and some don't, just depending on what you have. All right? What questions do we have? Anything? Awesome.